Okay, so what we're going to do is in the XY plane here, we're going to draw these points, and from the points we're going to be able to draw triangles, right triangles, that allow us to find the 6 trig functions of whatever my angle theta may be. So I'm going to start by plotting the point. Okay, so I have an angle where the terminal side goes through the point -3, -5. So -3 would go 1, 2, 3, and -5 would go 1, 2, 3, 4, 5. So if I plot that point, there's the terminal side of my angle. And theta is that entire angle there. Okay, but if I draw a right triangle for this thing, then I have gone 3 to the left and 5 down. Now technically they're both negative, right? But I don't want to focus on them being negative or positive, because if we're going to write the 6 trig functions, what allows me to determine the sign of them? We're in quadrant 3. So I can just use the numbers off of my right triangle to find the trig functions, and then I can assign a positive or negative to them based on the fact that we're in quadrant 3. All right, and so our theta goes all the way from 0 to the terminal side, but for our right triangle, we're just going to say theta is just the portion that is touching the x-axis. So the first thing we want to do is we want to find the hypotenuse, right? Because we need all 3 sides of the right triangle, and let's put the right angle in there. We need all 3 sides if we're going to write the trig functions. So my hypotenuse would be the square root of a squared plus b squared. So 3 squared is 9, 5 squared is 25, and 25 plus 9 is 34. And then I look at, can I simplify the square root of 34? Well, 34 is 2 times 17. And they're both prime numbers, so I can't simplify it any further. So we're going to leave it as the square root of 34. Okay, and then, like last time, we're just going to write out the 6 trig functions. So I want to find sine theta, cosine theta, tangent theta, and I want to find their reciprocal functions, cosecant. Let's give that a little more room. Let's put that up there. Cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. All right, so we're going to start with sine theta. All right, our theta is the one I marked in yellow. So opposite over hypotenuse. Opposite would be 5. Hypotenuse would be the square root of 34. And we got to rationalize that, right? So what happens when we rationalize it? We multiply by square root of 34 over square root of 34, and we're going to get 5 times the square root of 34 over 34, which cannot be simplified any further. But I'm not done, because now I have to assign it a positive or negative. We're in quadrant 3. Is sine positive or negative in quadrant 3? It's negative. Okay, so it's in quadrant 3, sine is negative. We're going to put a negative in front of this thing. Cosecant is the reciprocal, right? And if I'm going to take the reciprocal, I want to take the reciprocal of this one, not the rationalized one, because if I do the rationalized one, then I got to rationalize again. So we'll start with the first one. We switch it in cosecant, is going to be square root of 34 over 5, and since it's the reciprocal of a negative number, it's also going to be negative. All right, cosine is adjacent over hypotenuse, so we're going to get 3 over the square root of 34. We're going to rationalize it, and I guess I should be putting negatives on all of these. If I rationalize it, I'm going to get 3 times the square root of 34 over 34. And in quadrant 3, is cosine positive or negative? It's negative, so both of these would be negative. And then for secant, we take the reciprocal, and I'm going to take the reciprocal of the ratio I wrote down first. So we're going to get negative square root of 34 over 3. Tangent is opposite over adjacent. So we're going to get 5 over 3. Should it be positive or negative?
Negative.
Okay, quadrant 3, that T stands for tangent is positive. So it's going to be positive, and this 5 over 3 doesn't simplify, so cotangent, really easy. Just take the reciprocal. All right, this time we have the point negative 12, 5. So let's draw that. I'm going over negative 12 in the x direction and up 5. So I'm going to make that my terminal side. And if I draw my right triangle here, then we went over 12 in the x direction and up 5 in the y direction. My theta is the angle touching the x-axis. My real theta is out here, but the one we're working off is the one from the origin to the x-axis. Here's my right angle. Okay, and we're in quadrant 2, where sine is going to be the only thing that's positive when we do these. So first thing, we got to find the hypotenuse. Our hypotenuse is the square root of 25 plus 144. Okay, that's 5 squared plus 12 squared. And that comes out to be 169, and 169 is a perfect square. This is 13. All right, so I've got my hypotenuse now is 13. So we need our 6 trig functions. Sine theta, cosine theta, tangent theta, cosecant goes with sine, secant goes with cosine, and cotangent goes with tangent. So for sine, if we do opposite over hypotenuse, we get 5 over 13. Should it be positive or negative? It's going to be positive because we are in quadrant 2 where sine is the only thing positive. So cosecant will also be positive, and it's just the reciprocal. Cosine is adjacent over hypotenuse, so we're going to get 12 over 13. And if sine is the only trig function positive in that quadrant, that means cosine is going to be negative. Secant is the reciprocal. It's also going to be negative, so we're going to get negative 13 over 12. All All right, tangent comes from our TOA. It's opposite over adjacent. We're going to get 5 over 12. If sine's the only thing positive, that means tangent's going to be negative. Cotangent will be the reciprocal and will also be negative. So we get negative 12 over 5 for cotangent. All right, so first thing we do, we draw the point. So I'm going over 5 and then down 5 to get to this point. So there's my very crooked terminal side. All right, so if I draw my right triangle, it's going over 5. It's going down 5. There's my hypotenuse. There's my theta. Real theta is going all the way around to it, right? But the theta we're working with is the one that comes off the origin, touches the x-axis. If I want to find the hypotenuse, it's going to be the square root of 25 plus 25, which is the same thing as 2 times 25, right? Now, I could say it's 50 and then factor tree it, but I just happened to see that those were perfect squares, and it's 2 times perfect square, so I can write that as 5 times the square root of 2. So I've got my hypotenuse, 5 times the square root of 2. We are in quadrant 4, where the only thing that's going to be positive is cosine. Okay, so let's write out our 6 trig functions. We got sine theta. Oh, I'm going to have to rationalize these. Let me give myself some room. Sine theta, cosecant theta, cosine theta goes with secant, and tangent, and cotangent. All right, so sine, opposite over hypotenuse. We get 5 over 5 root 2. Well, that simplifies, right? Before I even think about rationalizing it, let's simplify it. So that is 1 over root 2. And if we rationalize that, what do we get? Give myself some more room here. Okay, that's off the unit circle, right, guys? We know what that is rationalized. That's root 2 over 2. And we are in quadrant 4, where cosine's the only thing positive, so we're going to make this negative. Now for cosecant, I want to take the reciprocal. I want to take the reciprocal from here, so I don't have to do any more rationalizing, right? So if I flip that one, we're just going to get the square root of 2, and it's going to be negative because sine was negative. Cosine is going to have the same value because this is an isosceles triangle, right? It's 45, 45, 90. So adjacent and opposite are both the same. So we're going to get 1 over root 2 again, because really what I got was 5 over 5 root 2, simplified as 1 over root 2, but I don't have to do that work again because it's the same numbers. And we're going to rationalize that and get square root of 2 over 2, and since we're in quadrant 4, that's where cosine's positive, so these are positive. Take the reciprocal for secant, and we're going to get root 2. Tangent, opposite over adjacent. What's it going to be?
5 over 5, which is 1.
5 over 5, which is 1, and in quadrant 4, that's going to be negative. Reciprocal of negative 1 is negative 1. Find the quadrant where theta lies with the given information. Well, this is pretty easy if we just draw our all-star trig class. Okay, so for question A here, tangent theta is less than 0. So tangent's negative. Well, tangent's negative in quadrants 2 and 4. So I'm in between 2 and 4 to make a decision here. My second piece of information is that cosine's positive. So where am I? Which quadrant?
4.
I'm going to be in quadrant 4. Okay, let's do the next one. Sine is less than 0. So sine is negative. If sine is negative, I'm either going to be in quadrant 3 or 4. My second piece of information is that cosine is negative. So am I in 3 or 4?
3.
I'm in 3. Okay, sine is less than 0. It's negative. That happens in quadrant 3 and 4. If cosine is greater than 0, then I must be in quadrant 4. All right, let's do part D. Cotangent is greater than 0. Okay, so let's rewrite these in terms of their reciprocal functions because those are the ones that are in the all-star trig class, right? So if cotangent is greater than 0, that means tangent is greater than 0. If secant is greater than 0, that means cosine. If it's less than 0, then cosine is less than 0. So now, let's look at our all-star trig class. Tangent's positive. Tangent's positive in 1 or 3. Cosine is less than 0. So where are we?
3.
We are in quadrant 3. Find cosine and cosecant if tangent theta is negative 2/3 and cosine theta is greater than 0. This is putting the last two examples together. Okay, if tangent is equal to opposite over adjacent, that's going to help me label two sides of the triangle. Where do I put the negative? We need to decide which quadrant we're in before we draw this triangle. So I have tangents negative. So we're actually going to draw this one. If tangent's negative, I'm either in 2 or 4, right? Cosine's positive. So which quadrant am I in? I'm in quadrant 4. So what I'm going to do is I'm just going to draw a hypotenuse in quadrant 4. I'm going to make it a right triangle by connecting it to the x-axis. So here's the theta we're going to use. And then if that's my theta, tangent is opposite over adjacent. My opposite, I'm going to label it as a 2. And my adjacent, I'm going to label it as a 3. All right, so we're going to end up using all-star trig class to determine the signs of these functions, or if I just look at this as being in the xy plane, which should be negative, the 3 or the 2? The 2 would be. But I'm just going to use my all-star trig class to figure it out. Okay, now we're missing the hypotenuse, so let's figure that out. It's going to be the square root of 3 squared is 9, 2 squared is 4, so it's the square root of 13. And then we're going to write out our 6 trig functions. Oh, I don't have to find all of them. Oops. Okay. All we got to find is cosine theta and cosecant theta. Didn't ask for all 6. And we know cosecant is 1 over sine, so let's find sine theta first to make it easier to find cosecant, right? Okay, so cosine theta is adjacent over hypotenuse. That's going to be 3 over the square root of 13. We're in quadrant 4, where cosine's positive, so it's going to be positive. And we're going to rationalize it and get 3 times the square root of 13 over 13. Now sine is going to be opposite over hypotenuse, so we're going to get 2 over the square root of 13. And in quadrant 4, where cosine is the only thing that's positive, we're going to say this is negative. And I don't have to rationalize that one because they didn't ask me about sine, they asked me about cosecant. So we've got that, we can take the reciprocal, and we'll have our answer for cosecant. We want to find sine theta and tangent theta if secant theta is negative 3 and tangent theta is positive. Okay, now if secant theta is negative 3, secant goes with cosine, so cosine would be negative 1/3, right? So when we're trying to figure out what quadrant it goes in, cosine's negative. So cosine's going to be negative either in quadrant 2 or 3. And it says tangent's positive, so we're in quadrant 3. So I'm going to draw my right triangle. And we have cosine is negative 1 over 3. So my adjacent, remember here's my theta. My adjacent side to theta is 1. My hypotenuse is 3. So we need to find the opposite side length. So if we label this as A and this is B, then C is always the hypotenuse, right? So for A squared plus B squared equals C squared, we're going to need to rearrange to solve for B. B is going to be the square root of C squared minus A squared. So using our numbers, that's going to be 9 minus 1. That's the square root of 8. And 8 can be simplified. Right? 8 is 2 times 4. 4 is a perfect square. So we can rewrite that as 2 times the square root of 2. Alright, so that's my side length B I'm going to put over here is 2 root 2. Okay, so we've got all of our side lengths. We want to find sine theta and we want to find tangent theta. And the fact that we're in quadrant 3 tells me tangent's going to be positive, but sine's going to be negative, right? So if sine's negative and it's opposite over hypotenuse, opposite is 2 root 2, hypotenuse is 3, and we make it negative. Tangent is opposite over adjacent, so I've got 2 times the square root of 2 over 1, and it's positive because we're in quadrant 3 where tangent is positive. And we're not going to write that as being over 1 because dividing by 1 just gives us our numerator. All right, this one. You know how to do this off the unit circle. The quadrangles, we want to evaluate sine and tangent at the quadrangles. Remember, we talked about those. Those are the angles that divide our xy plane into the quadrants. So we care about 0, pi over 2, pi, and 3 pi over 2. The coordinates that go with those, at 0, we're at 1, 0. Pi over 2, we're at 0, 1. pi, we're at negative 1, 0. 3 pi over 2, we're at 0, negative 1. Okay, so let's do sine first. Sine of 0, remember our coordinates are cosine comma sine, so sine of 0 is 0. Sine of pi over 2, I'm getting it from right there, is 1. Sine of pi is 0. Sine of 3 pi over 2 is negative 1. Okay, so it said evaluate if possible. The if possible comes in with our tangent. Tangent of 0. Tangent is sine over cosine, so we're going to get 0 over 1, which is 0. Tangent of pi over 2 is going to be 1 over 0, and what do we write for that? It's undefined when we divide by 0. Tangent of pi is 0 divided by negative 1, so that's just 0. And tangent of 3 pi over 2 is negative 1 divided by 0, so again, we'll write undefined. Okay, a reference angle, it's the theta that we were using in all of those triangles. And the easiest way to describe it is it's the quickest way to the x-axis. So if I look at these three different cases, in the first case, the quickest way from where I am, so my true theta is more than 180 degrees, right? But the theta I'm going to use for my reference angle for finding my 6 trig functions is going to be the quickest way to the x-axis. So I could either get there by going clockwise like I just did, and we're going to call the reference angle theta prime, or I could have gone all the way over this way. Well, that's not the quickest way to the x-axis, right? We want the quickest way. So we definitely don't want that yellow one. Okay, in situation 2 here, quickest way to the x-axis is right there. And in situation 3, my quickest way to the x-axis is right there. So in situation 1, if I wanted to find that reference angle, I would take the angle I was given and subtract 180 from it. I would take this part of it away. That's 180, right? In the second case, I would start with 180 and subtract the theta from it, and it would leave me with the reference angle. So just stick with me. This is going to make sense when we do it with some numbers in a second. In my third case, the best way to calculate that angle would be to say, well, I went all the way around almost to 360, so I could do 360 minus the theta I was given, and that would leave me with that acute reference angle. All right, so let's do some. If I have 345 degrees, okay, what do I know when I'm in degrees? I know this is 0, this is 90, this is 180. If I add 90 to 180, I get 270 here. So 345, and then all the way back around is 360, right? Let's do that. So 345 is somewhere in this quadrant. So I'm going to say that's 345 degrees, going all the way around. And I want to know what is left to get me to the x-axis. So to find that, I'm going to do 360 degrees minus 345 degrees, and that gives me 15 degrees. So the reference angle, the amount that's left to get me to the x-axis, was 15 degrees. Okay, if I do 5 pi over 6, well, we count around with our pi over 6s, right? There's 1, 2, 3, 4, 5. So I'm right here at 5 pi over 6. So that's that full angle. What is left to get me to the x-axis? Well, at the x-axis, we'd be at pi, right? And pi is the same thing as 6 pi over 6. If we subtract 5 pi over 6 from it, I get pi over 6. Now think about our unit circle. This makes sense because where I am now, when we use the unit circle and we draw those rectangles, right, that one matches up with pi over 6, which would be symmetric with the one that we drew for 5 pi over 6. If they're negative, it just means we rotate in the other direction. So if I'm going negative, this would be negative 90 degrees, this would be negative 180, this would be negative 270, and I'm writing those just so I know where to draw the terminal side. So negative 135 is going to be somewhere in between negative 90 and negative 180. So let's put it in there. Okay, so that's negative 135. Then in order to get to the x-axis, I'm trying to find this distance. Well, so that's really close to 180. I could even mirror image this with positive numbers, and it would be in quadrant 2 instead. But the way I'm going to get this reference angle, and reference angles are always positive, is I want to know what's the difference between 180 and 135. I'm going to ignore the fact that they're negative and just find the angle that's in between them. And 180 minus 135 is 45. Okay, so if I don't give you the point, if I don't give you the information that tells me where to draw the terminal side of the rectangle and the right triangle, all that good stuff, then I can use reference angles to find the trig functions if they are one of our special angles. Okay, so 135. Well, that's in between 90 and 180, right? So let's draw my terminal side there. So 135 goes from here to here. 180 minus 135 will give me 45 degrees as a reference angle going from here to here. Well, if that's my reference angle, 45 is the same thing as pi over 4, right? Sine of 45 degrees is the same thing as sine of pi over 4. Sine of pi over 4 we know is root 2 over 2. Now I'm in quadrant 2. So let's put our all-star trig class on here. Quadrant 2, sine is positive. So what this tells me then is that sine of 135 degrees is the same thing as sine of 45, which was the reference angle we used, and it's positive because we're in quadrant 2. Last one. Tangent of 14 pi over 3. Well, to get a reference angle for this, 14 pi over 3, that's more than 2 pi, right? So before I can even get a reference angle, first we got to find a coterminal angle between 0 and 2 pi. Right? Otherwise I'm going to be looping around and around and around and around. So we want to find the coterminal angle first. That's a symbol for angle if you've never seen it before. So we're going to do 14 over 3 minus 2. All right, we did this with our calculator the other day. We leave the pi off, we type it in the calculator. 14 over 3 minus 2 gives me 8 over 3. That's still more than 2 pi. So we do it again. 8 pi over 3 minus minus 2 pi gives me 2 pi over 3. All right, so now we're at a number between 0 and 2 pi. We can go ahead and find our reference angle. And we know exactly where 2 pi over 3 goes on the unit circle, right? All right, that's pi over 3. That's 2 pi over 3. So that whole angle is 2 pi over 3. Now this over here is pi. Quickest way to the x-axis is the difference between those. Well, pi is the same thing as 3 pi over 3, right? 3 pi over 3 minus 2 pi over 3. This right here is pi over 3. And if we do all-star trig class, sine's the only thing positive there. We're trying to find tangent. So we're going to find tangent of pi over 3, and tangent of pi over 3, well, pi over 3 here is 1/2 root 3 over 2. So what do we get? Sine over cosine. Flip it and multiply, that simplifies to be square root of 3. So we're going to get the same value except for we're in quadrant 2 where tangent's negative.